Hello students, today I am going to discuss Cambridge A-level chemistry October November 2022 paper 22 paper 2 written paper November 2022 paper 22. Please subscribe, like and share my channel. Let's move. Number 1. Species say ammonium ion, carbonate ion and phosphate ion are examples of molecular ions. These are molecular ions. Ammonium ion, carbonate ion, phosphate ion. A. Ionic and covalent bonds both involve an electrostatic attraction between different species. Identify the species that are electrostatically attracted to one another in an ionic compound. An ionic compound oppositely charged ions attract each other, or you can write cations and anions. Cations means positive ion, anion means negative ion. A covalent bond, shared pair of electrons and two nuclei. This is the covalent bond. There is attraction between shared pair of electrons and nuclei of atoms. Two nuclei, plural number. This is shared pair of electron. This is nucleus, nuclei. This is shared pair of electron, two electron share. So the attraction between shared pair of electrons and nuclei of atom is known as covalent bond. Next, B. Complete the table to show total number of proton. You have to show total number of proton and electrons in the molecular ions. Ammonium ion, carbonate ion, phosphate ion. You will have to show proton number and electron number. You see this ammonium ion here, nitrogen proton 7, hydrogen 4, so total 11, and total number of electrons, nitrogen 7, 4 hydrogen 4, 11 plus 1 means 1 electron less, so 1 electron will be less and number of electron will be 10. Now carbonate ion, total number of proton, carbon is 12, oxygen 8, 3 oxygen, 8 3s are 24, carbon 6, atomic number 6 means 6 electron, and oxygen atomic number 8, 24, total 30 electron, total here 30 electron. Carbonate ion, carbon 6, oxygen 8 times 3 24, 24 plus 6 this 30 electron, 30 proton total. 6 plus 24, total proton number 30. Now number of electrons here, proton number 30, so negative 2 electron means 2 electron more, so number of electron will be 32, 30 plus 2. Then phosphate ion, phosphorus 15 electron, oxygen 8 times 4, 32. So total electron will be 47. 15 plus 32, total number of proton will be 47. Then total number of electron will be, as proton number 47, but here negative 3 means 2 electron more, so 47 plus 3, 50 will be the total number of electrons. Now ammonium ion is a Bronsted Lowry acid. Define Bronsted Lowry acid. Acid means proton donor. Proton means hydrogen ion, gives hydrogen ion. Number 2, when ammonium ion is heated with sodium hydroxide, a pungent gas is produced. Write an ionic equation for this reaction. This is the ionic equation. Ammonium ion reacts with hydroxide ion to form a pungent gas, ammonia gas plus water. This is the ionic equation. Ammonium ion reacts with hydroxide ion to produce ammonia gas plus water. Next, number 3, sketch the shapes of 2s orbital, and you know s orbital is spherical, and p orbital 2px, p orbital you know dumbbell shape. So as 2px, so this lobe will be along the x-axis. S orbital is spherical, p orbital dumbbell shape. This is the shapes of 2s and 2px orbital. Now name the anion PO4 negative 3, this phosphate 5 ion, phosphate 5, Roman number 5, because here phosphorus oxidation number is 5. 4 to the 8, negative 3, so 5, phosphorus will be plus 5. There's this anion name is phosphate 5. Next one, a hydrated mineral AMR is given, 243.6 relative molecular mass is given. Hydrated means with water. The anhydrous means without water of this mineral has the formula ammonium magnesium phosphate. Total hydrated mass this, anhydrous formula this. Calculate the number of molecules of water of crystallization in this hydrated mineral. Now we see molecular mass of anhydrous mineral, nitrogen 14, hydrogen 4, magnesium 24.3, phosphorus 31, oxygen 16 times 2, total 137.3. This is the anhydrous mass. So relative molecular mass of anhydrous mineral 137.3, total hydrated mass this. So mass of water will be total mass minus an anhydrous mineral mass. So mass of water will be 108 gram. Now moles will be mass divided by water molecular mass, 108 divided by 18x. So number of molecules of water of crystallization will be 6 mole water. Let's move next one. This is from organic chemistry. SN1 mechanism. Hydroxide ion reacts with 2-bromo-2-methyl propane. This is the 2-bromo-2-methyl propane. Why? 1, 2, 3. 2 carbon contains bromine and 2 carbon contains methyl. So its name will be 2-bromo-2-methyl propane in an SN1 mechanism. So this is the tertiary, this compound is tertiary haloalkane. Why? Halogen containing carbon is attached to 3 others carbon or 3 others methyl group. Halogen containing carbon directly attached to 3 methyl group. That's why this is known as tertiary haloalkane. In tertiary haloalkane, SN1 reaction mechanism occur. So now draw the mechanism for the SN1 reaction with hydroxide ion with 2-bromo-2-methyl propane. You see, first electron is going to bromine atom because bromine is more electronegative. So carbon become partially positive, bromine become partially negative. So bromine is going, bromine is removed, carbon forms positive ion. This is known as carbonium ion or carbocation, positive carbon. Then this hydroxide ion gives its lone pair electron to form positive carbon, to form bond with carbon. So this is haloalkane and this is alcohol. This is SN1 reaction mechanism. Now 2-bromo-2-methyl propane is a tertiary bromoalkane. Define the tertiary bromoalkane. Already I told the CBr carbon is bonded to 3 other carbon atom. What is tertiary bromoalkane? CBr carbon. CBr carbon means this carbon. CBr carbon. This carbon is attached to 3 others carbon. That's why this is tertiary bromoalkane. The CBr carbon is bonded to 3 others carbon atoms. Now you see, organic compound M forms when 2-bromopropane is heated with ethanolic alcoholic hydroxide ion. Draw the structure of op-amp, and you know haloalkane when reacts with ethanolic sodium hydroxide or ethanolic hydroxide, alkene will be produced by elimination reaction. So how this reaction happen? You see this 2 bromo 2 methyl propane, here 2 bromo 2 methyl propane, here bromine goes as bromide, 1 hydrogen go here from neighboring carbon of bromine, this bond go this to form double bond. So this name will be methyl propene or 2 methyl propane. Now the structure of M will be 1 2 3 propene, 2 carbon contains methyl, so this will be 2 methyl propene, 2 methyl propene. Okay, now next, this question number 2. The chlorides of some period 3 elements are shown in this period 3 chloride, all are chloride. Bonding, structure, oxidation state. Identify the bonding shown by each chloride under standard condition. Use C for covalent, I ionic, M metallic. And identify the structure shown by the chloride. Use Z giant, S means simple. Deduce the oxidation state of the period 3 elements in every chloride. Now you see sodium chloride ionic, aluminum chloride you can write ionic or covalent. C. Silicon tetrachloride covalent, phosphorus pentachloride this covalent, carbon PCl3 PCl2 these are given. Structure sodium chloride giant, aluminum chloride giant, silicon tetrachloride simple, phosphorus pentachloride simple. The others two also simple molecule or simple covalent. Now oxidation state sodium chloride, here sodium plus 1, here plus 3, silicon plus 4, phosphorus group 5 plus 5, here chlorine negative 3, so phosphorus plus 3, here 2 chlorine negative 2, sulfur will be plus 2. This is their bonding, structure and oxidation state. Now you see number B. Write equation for the reaction of sodium chloride and phosphorus pentachloride with water. Include you state symbols in both equations. You know, when sodium chloride is a solid, if you add water, this is liquid water, they just dissolve and they form ions. Sodium ion aqueous plus chloride ion aqueous. They don't react, just they dissolve in water, they form ion dipole. Sodium ion aqueous, chloride ion aqueous. Phosphorus pentachloride simple covalent molecule, so it hydrolyzes. Phosphorus pentachloride is solid, white solid, it reacts with water, reacts with water to form phosphoric acid aqueous and hydrochloric acid aqueous. This phosphorus pentachloride hydrolyzed in water to produce two acid, one is phosphoric acid and other is hydrochloric acid. Now Number C, in gas phase aluminum chloride exists as at equilibrium with Al2Cl6 dimer. Two aluminum chloride molecules combine to form dimer. This is exothermic reaction. Now you are asking complete the dot and cross diagram to show the bonding in Al2Cl6. Now you know they form two dative bond because chlorine, aluminum has 3 electrons in its outer shell, so it can form 3 covalent bond. Now this aluminum 1 covalent bond, 2 covalent bond, 3 covalent bond. So if aluminum bond form 4, so chlorine gives its lone pair to form dative bond with aluminum ion. One chlorine atom form one dative bond to one aluminum atom, and similarly this chlorine atom gives 2 electron to aluminum to form another dative bond. And chlorine 6, if 1 here, 2, 4, 6, 2, 1, 2, 3, 4, 5, 6. This chlorine 2 electron give here, 1 here, remaining 4. This is the dot and cross diagram of Al2Cl6. Here there are 2 dative bond. Now state the effect of an increasing temperature on the equilibrium mixture in equation 1. Explain your answer. Increasing temperature, and you know if you increase temperature according to La Chatelier's principle, reaction need to be decreased temperature. If it go to the endothermic direction, it will absorb heat and temperature decreases. So as temperature increases, it will go right to left. Equilibrium shifts to left hand side, means right to left hand side, because forward reaction is exothermic reaction. As forward reaction is exo, so if you increase temperature, it will try to decrease temperature. That's why it will go right to left. Okay, now next. Number D, a 3.3 gram of sample of period 3 chloride heated. Mass is given, temperature is given Kelvin. At this temperature, the chloride is a gas of volume is given 250 centimeter cube, and the pressure in the flux is 323 kilopascal. Pressure is given in kilopascal unit, temperature and volume is given centimeter cube, temperature Kelvin is given, and mass gram is given. Use the idea of gas equation Pb equal nRT to calculate MR, relative molecular mass of the period 3 chloride. Deduce the formula also. Now you see Pb, you know Pb is given, Pb equal nRT, so n will be Pb RT divided by R RT. Now V is 250 times 10 to the power negative 6. It has been converted to meter cube. And P 323 kilopascal, 3.23 10 to the power 5. This has been converted to Pascal. Now R value is 8.31 and T is 500. If you calculate, you get this mole. Now you know molar mass equal number of mole is equal mass in gram divided by molecular mass. So molecular mass will be mass divided by number of mole. You get 170. So silicon tetrachloride molecular mass will be 170. Silicon 28, 4 chlorine 35.5 times 2, 142 times 4. You will get 170. 170 is the molecular mass of silicon tetrachloride. So you have to remember here, kilopascal have to convert it in pascal and centimeter cube have to convert it to meter cube. Now next one, an excess of chloride ion is added to 1 centimeter cube of aqueous bromine solution. Describe what is observed. Explain your answer. Here orange color of solution remains same because bromine cannot oxidize chloride ion. Bromine is less reactive, so bromine cannot oxidize chloride ion. So solution of orange solution remain color. Orange solution color will remain same. Now number 2, sulfur dichloride has molecular mass 103.1 and is liquid at room temperature. Sulfur dibromide has molecular mass 191.9 and is gas at room temperature. Explain the difference in the physical state. Sulfur dichloride is liquid but sulfur dibromide is a gas. What the difference? Give your answer in terms of intermolecular forces. Chlorine is more chlorine is more electronegative than bromine. Chlorine is more electronegative than bromine. So permanent dipole forces in SCl2 are stronger because sulfur dichloride is more polar. Why more polar? Because chlorine is more electronegative than bromine. So in sulfur dichloride, dipole force is stronger than sulfur dibromide because sulfur dichloride is more polar. Why? Chlorine is more electronegative than sulfur. Now F, bismuth is a metal, a dense metal in the same group as phosphorus. So draw a label diagram to show the bonding in bismuth metal, and you have to draw label diagram bismuth metal. Metal and metallic bond, metal forms positive ion, all bismuth ion positive ion. Then loose electron, these electrons are delocalized electron. So plus one is positive ion, positive metal ion, and electron is delocalized electron. So what is metallic bonding? The attraction between positive metal ion and C of delocalized electron is called metallic bonding. That's why this plus one is positive ion and electrons are delocalized. Delocalized means mobile electrons. They can move easily. So label positive ion, these electrons delocalized electrons or mobile electrons. Bismuth is a metal, so you have to diagram of metallic bonding. Now, number 2, bismuth reacts with chlorine to form bismuth trichloride, BiCl3. Bismuth trichloride is a solid at room temperature and it melts when heated gently. That means its melting point is low. Bismuth trichloride reacts vigorously with water, hydrolyzed it is, at room temperature to form an acidic solution. Suggest the type of bonding and structure shown by bismuth 3 chloride. Explain your answer. Structure will be simple because it has a low melting point. Why? Because it melts when heated gently. That means it has low melting point. So that's why it is a simple molecule. Now, what type of bonding present? Bonding is covalent because it is hydrolyzed, as bismuth trichloride reacts vigorously with water at room temperature to form an acidic solution. So bonding will be covalent because it is hydrolyzed. Okay, now next. Number 3, this is from organic chemistry. Organic compounds can be distinguished using chemical test. By chemical test you can distinguish organic compounds, and analytical techniques also you can apply. Now you are asking table 3.1 shown 4 pairs of organic compounds. This table shows 4 pairs of organic compounds. Now pair 1, A1, A2, reagent, positive result. Now you see this is aldehyde because aldehyde functional group. This is ketone. One is aldehyde, other is aldehyde, ketone. So distinguish aldehyde and ketone. Very simple. You can use Fehling solution. A1 gives brick red PPT. PPT means precipitate because aldehyde gives red precipitate with Fehling solution. Aldehyde give precipitate with Fehling solutions. Or you can write potassium dichromate. Potassium dichromate oxidize aldehyde. So solution turns orange to green for A1, but ketone does not oxidize, so no reaction. Or you can write alkaline aqueous iodine solution, I mean iodoform test, and methyl ketone. This won't react. A2 as A2 is the methyl ketone, so it will gives yellow precipitate A2. So you can easily distinguish A1 and A2 with any of these 3 tests. Any one you can write in exam. Number B1 you see and B2. This is ketone, methyl ketone, and this is ethyl ketone, CH3 CH2 ethyl ketone. So you can distinguish alkaline aqueous iodine, I mean iodoform test. Methyl ketone gives yellow PPT. Okay. So you can distinguish easily B1 and B2 with alkaline aqueous iodine, I mean with iodoform test. Now how you can distinguish CO1 and C2? So this is ketone, this is ester. If you add 2,4-DNPS, I mean 2,4-dinitrophenylhydrazine, this is an organic compound, and any carbonyl compound, I mean aldehyde ketone, reacts with 2,4-DNPS to give yellow or orange or red precipitate, but ester does not give this test. So you can easily distinguish ketone and ester by reacting with 2,4-dinitrophenylhydrazine. C1 gives yellow or orange or red precipitate because C1 is a ketone. Now this is an alkene. So now this is an alkene and this is alcohol, tertiary alcohol. So D1 and D2 you can easily distinguish by adding bromine water or aqueous bromine, because alkene reacts with aqueous bromine to form dibromoalkane and orange solution turns to colorless. So D2 will react with bromine water and bromine water turns orange to colorless, but D1 will not react. So you can distinguish D1 and D2 by reacting with aqueous bromine or bromine solution. Now next, to A1, A2 are structural isomers. Define the term structural isomers. Molecules with the same molecular formula will be same, but different structural formula are called isomers. Molecules with the same molecular formula but different structural formula are called structural isomers. Structural isomers. Now next one, give the systematic name of B2. B2 is a pentan 3-pentanone, because B2 is 3-pentanone. B2 1, 2, 3, 4, 5. So 3-pentanone. Systematic name is 1, 2, 3. Functional group is in 3 number carbon. So this is 3-pentanone or pentan 3-one. Now you see 4. Deduce the molecular formula of D1. If you count, you get 5 carbon, 10 hydrogen and 1 oxygen. Molecular formula shows the whole number of atom. So here 5 carbon, 10 hydrogen, 1 oxygen. Okay. Now D2 forms polymer Z when heated gently. Identify the type of polymer that forms from D2. This polymerization type will be addition polymerization. Why? D2 is an alkene. D2, you see, D2 is a alkene. It has carbon-carbon double bond, so it will form addition polymerization. Now polymer will be addition polymerization, addition. Then this is the D2. This is D2. Now number 2, draw the repeat unit of this polymer Z, and you know this double bond here, one carbon, two hydrogen, one hydrogen above, another hydrogen below, and left hand side one bond open. Now right carbon has one hydrogen, so I write one hydrogen below, and one carbon, one side contains CH2 CH2 OH, CH2 CH2 OH, bond is open here, right hand side bond open, left hand side open. Reaction will happen here. Now this is from infrared spectra. Organic compound E contains 3 carbons. This information will be needed for next question. 3 carbon atoms, and E reacts with cold dilute KMnO4. You know cold KMnO4, diol is formed, dihydroxy alkane is formed to form a single compound F with molecular mass 154.9. Now 3.1 figure shows the infrared spectra of E. This is the E, and 3.2 shows the spectra of F. These are given. So now you see the what is asking. This is the spectra of E, IR spectrum. This is our infrared spectra of F. Now let's move. Their bond given and their absorption range, wavelength, wave number is given. Now you see both spectra shows absorption between 28502 and 29 due to CH bond. So use the two infrared spectra and this table to identify the functional group present only in E. So E has functional group carbon-carbon double bond, alkene. And referring only to absorption, E at frequencies greater than, you have to mention greater than wave number 1500 per centimeter, carbon-carbon double bond. Why you see carbon-carbon double bond? Shows peak, you see carbon-carbon double bond shows peak this value, absorption with 1500 to 1680 per centimeter. So this is alkene. Now we go next one. Next one, use the infrared spectra of F to identify the functional group formed when E reacts with cold KMnO4. That means diol is formed, alcohol is formed. So functional group will be hydroxyl or alcohol. Hydroxyl or alcohol, because absorption within this range 3200 to 3200 to 3650 per centimeter. So Number 3, the mass spectra of E shows a molecular ion peak and a M plus 2 peak of approximately equal abundance. M by E value is 120 and 122. Now deduce the relative molecular mass of MR of E. If you mass 120 times 50 because equal abundance plus 122 times 50 divided by 100, you got relative molecular mass 121. Now next one. You see, 4. Use the information in 3.6 to suggest the structure of E. So E will be bromopropene. 1, 2, 3. Bromopropene. Bromopropene. Here if bromopropene reacts with cold KMnO4, so bromopropane diol form will be formed, and this mass will be 154.9 because this is given here. Bromopropane diol molar mass F is given 154.9. So E will be this compound, bromopropane. Now 5. Complete the equation for the reaction of E. E means bromopropane, cold KMnO4, potassium permanganate, to form F. F means this compound. So one OH bond will be added here, other hydroxide group will be added, double bond becomes single bond. This reacts with this to form C3H7Br O2 because 2 hydroxide group will be added. So 2 oxygen and 2 hydrogen will be increases. Here 3 C3 H5, so 2 hydrogen increases, H7 Br and 2 oxygen O2. This is the equation. Bromopropane reacts with cold KMnO4, potassium permanganate, to form bromopropane diol. Bromopropane diol, this. One hydroxide will be this carbon, this. Other hydroxide will be this carbon. Now C2 is an star. 1, 2, 3. Propyl propanoate is a star. Is synthesized means can be made. Using as a single organic reactant. You can only one organic reactant. So only you can use A1. A1 is the 1, 2, 3 aldehyde, propanol. So devise a multi-step synthetic route to form C2. From A to C2 you will prepare using only one reactant by different routes. Identify relevant reagents. You have to require reagent, conditioned, and state the organic product of each step. Now you see A1 is aldehyde propanol reacts with sodium borohydride in the presence of dry ether to form propanol. I mean, aldehyde goes to primary alcohol by the reduction with sodium borohydride. Here condition in presence of dry ether. Aldehyde go to primary alcohol by the reduction reaction. Then propanol reacts with acidified potassium dichromate to form propanoic acid. This is oxidation reaction. Propanol is oxidized by acidified potassium dichromate to produce propanoic acid. So you get here propanol and you get here propanoic acid. This our ester is propyl propanoate. So propanol reacts with propanoic acid in presence of sulfuric acid to produce C2. To produce C2 means propyl propanoate. I mean, propanol reacts with sulfuric acid. Propanol reacts with propanoic acid in presence of sulfuric acid catalyst to produce propyl propanoate. I mean C2. C2 is the name of propyl propanoate. Okay, thank you students. Please subscribe, like and share my channel. Thank you.